In this lesson, we're going to talk about create, read, update, and delete operations on a SQLite database. If you remember our last project, we did create the database, and we did insert some data, but we didn't really talk about that, so we'll go over that. This is our form, where we have a create database. The prove it does a select. We have an update and delete. If we take a look at the code, we'll get into that insert data. We have a database path that we created earlier using our database name and an environment folder and combining those into a path. We create our SQLite connection saying that the data source is equal to that database path for the connection string. And then we create a SQLite command. And we set the command's connection equal to that connection object that we created. And we open the connection. Our SQL string is a simple insert statement. We're inserting into the customers table a first name, last name, and a state ID, and we're doing this as a parameterized query. So our command text is equal to that SQL, and of course our command type is a text command. And we add in our parameters for first name, last name, and state, and we're just going to put in Bob Johnson and we'll use the first state. And we execute that as a non-query. And then we'll do it again and create a record for Sue Robinson in the second state. And again, execute non-query. After those queries are done, we close our connection and then we dispose of it. And just put up a little message that the commands were completed. So that's the inserts. The prove it click actually does a select. And again, we create our database path. Often in production code, you're just going to do this once and there'll be either a static string somewhere or it'll be a property off of the application. So again, we create our SQLite connection. And in this case, our SQL is a very simple select statement. We create our SQL command, this time a different variation, using the SQL and the connection. Again, the command type is text, and we open it. And we're just going to go through and read the two records that we've put in and collect that data into this string variable. So we create a SQLite data reader and execute that reader on the command and start reading. And for each record that we read, we put in a customer ID, a first name, and a last name, essentially in a comma delimited line. And we put that in our little proof text view. And finally, we close the connection and dispose of it. So that's how we can read data. If we want to update data, all of this is the same in terms of opening a connection. And again, SQLite command, open the connection, and here's our SQL. Did a little parameter on this one as well. It's a simple update customers where we set the first name and of course a where clause, just setting the customer ID. And we update that first name from Bob to Robert. And we execute the query. And as always, we close and dispose of the connection. And finally, our delete is all very similar. In fact, all of that is exactly the same as the update. And finally, we have a little SQL, a delete from the customers, where the customer ID is parameterized, and we're just going to delete the second customer. So those are the basic database operations, and if you're familiar with .NET database programming, none of this should come as a particular surprise. So we'll give that a run. Okay, we'll create our database, and that will insert the data, and proving it, we'll select our records. So I have Bob Johnson and Sue Robinson. If I click on Update, it says my command is completed, and let's prove that. Bob Johnson is now Robert Johnson. And if I delete a record, and we prove it, and now Sue Robinson is no more. So those are your basic database operations done in relatively standard .NET code. The benefit of using this kind of technique as opposed to the SQLite Open Helper is that this code is transportable to Mono for iOS, so that you wouldn't have to port your code base over if you were going to support both iPhone and Android platforms. So that's a pretty large benefit. Now granted, the code is a bit longer and perhaps a little bit uglier, but it can be put in a data layer and handled pretty easily in there. Next, we'll take a look at how to handle data in lists. We've already done a lot of work with lists, but now we want to actually populate them using the database.